Hey folks, as promised, I'm bringing you back here with pretty much all of the fabrication done here on the housings. In the last video, I mentioned I would come back to this whole project once I got, all of these upper link mounts done. What else was there? Anti-roll bar mounts, driveline cage mounts. Basically everything that needed to be welded and done up here on these housings is now finished. The reason for the long prelude to this video is because there is a tremendous amount of work and hours into finishing up these parts, and I didn't want to just skim past them. So I don't know exactly how many hours are tied up into that thing, into both of these housings, but basically it's 2 full sets of days off of, designing parts, cutting parts out, welding, all of the stuff that I'd already designed and cut and had tacked together on the knuckles. I ended up getting that stuff all welded up. To do the knuckles, I had to disassemble them, pull the champagne out of the knuckles with the bearings, reassemble the 2 halves of the knuckles together, and then preheat and weld. And even after disassembly, once you started right at the level of preheat and then start welding, by the time each knuckle was done, I had between 2 and 2.5 hours of welding on each one of those components. So yeah, there's just a lot of work into getting all of this stuff done, and I simply just didn't want to skip over it. So not only do I have all of the welding done on the housings and the knuckles and that stuff, going, pretty much ready to assemble, I actually have the rear already done. So I've really been putting a lot of time into this thing. If I can have this truck done and running and be at a competitive state by it's the 9th, the weekend of the 9th of August. I actually have it set up, it could be at 2 shows that weekend. So I'm pushing really hard to get this thing done and, ready to go. I don't want to scab it together just to make a show. I want it to be together, assembled, and working right, but I've just been pouring all the time I can into it. As a matter of fact, right now I'm here after work, and I usually don't work in the shop, after my day job. I usually save that for my days off. I have plenty of days off to work down here, but I don't have plenty of days off before the weekend of August 9th and 10th. So here I am, the last week I've been down here, putting a couple hours in a night after work and trying to get these things done. So as I mentioned, the rear is finished. I painted it last night. It's sitting there dry. It's pretty much ready to go in the truck. The front completely needs assembled. Now, I did do some time-lapse work doing the rear, and I'll share that in this video as well. But I will try to do more, good content and good video of actually assembling this front. Now, one thing that I said I would do that I unfortunately will not be able to is getting into the third members. Now, I had mentioned in the last video that I have to install a spool in the rear axle, which that one does. I installed the spool in that rear axle. And to do that, basically you have to pull the ring gear out, that carrier assembly, pull the 2 halves of the carrier assembly apart, pull the sides and the spider gears out, install the spool, bolt those 2 halves back together, put that whole assembly back in the third member, and then the third member is ready to put in the housing. So the only part of that I covered or got any content on was basically just putting the spool in that center carrier. I was using that time on the rear third member to figure out how I wanted to video and kind of go more in depth on that. And then I figured I would just do a good video on installing the Detroit locker for this front axle. Now the Detroit locker is a little bit more interesting than a spool, and that's why I kind of saved that, for the actual video. Unfortunately, I have decided that for 2 reasons. 1, to save time. 2, I really want to try the front differential open without a locker in it. So instead of completely disassembling the front third member to install the Detroit locker, I'm actually just going to clean up the front third member, get it all washed out, and dump it in the housing as is. I want to run it open front diff. Now, I've already got the locker, so it's going to sit on the shelf. If I need it or decide I absolutely have to have it, it's ready to go in. We can look into that more at that time. But really, if I don't do it, which I want to try it open diff, but also it saves me several hours of disassembly, cleanup, putting that locker in, making sure everything's right there, reassembly, which you have to mess with preload on the bearings, making sure your pattern all runs right. It just saves me a bit of time by not running that right now. And time is really critical. So unfortunately, I am not going to be able to, go more in depth on the third member. I wish I could do that. Maybe we'll do, like a full length video on doing that. My plan actually is, if the gear ratio that I've selected for these axles works out, if I really like that gear ratio, I will find a spare unit, a third member, and then take that one apart, put the locker in it, and then have that one sitting ready to go in. If I ever have a problem with one of these differentials, I could drop that spare in really quickly and have the truck back up and going. If I choose to not run the 557 gear ratio that I have selected here, if I decide I need a taller gear or a lower gear, I can make that change rather than, before I start buying spare parts. And at that time, more than likely, the Detroit locker will go in there. So enough on the third members. What I'm going to do is I'm going to turn this camera around, kind of go over some of the stuff that I've done as far as the welding and some of the work that's went into it. Then I'm going to set the camera up and get busy starting to assemble this thing. Well, like I said, there was a ton of work in getting these things wrapped up. Starting with the upper link mounts, they're cut out a 1/2-inch plate, just like the lower link mounts were. All of these areas that are, they're spanning a distance are all boxed in, plated in with gussets. The lower shock mounts, like I'd mentioned in the previous video, they were built off of this flat pad area that I designed specifically to build off of for the shock mounts. This front plate for the lower shock mount is actually press broke so I could keep that footprint on this this flat plate that I was designed to land the shock mounts on. Also, I tried to integrate a lot of these parts together. Like you can see here, this rear plate on this lower shock mount has a location basically to mount my lower anti-sway bar mount. That's what this mount right here is for. And then these are the driveline cage mounts that I'd also mentioned in the previous video. So yeah, tons of work, lots of welding, lots of cutting, lots of grinding, not necessarily in that order. Then once all of this was done on both housings, the knuckles were disassembled, pulled the champagnes out, reassembled the two halves of the knuckles, and got all of this stuff welded up. As you can see, like I'd mentioned, this is a laminate plate. So it's basically this plate is just welded to this plate. This spacer is welded in place to both upper and lower plates here. And I had mentioned previously that I was going to box this all in to make it stronger. But a plate or a gusset in this plane is not really offering the strength that I'm looking for in this application. It would help strengthen this upper plate, this upper double shear plate, but I don't really need strength there. I have a great big EMF Heim that bolts in right here that's going to strengthen that all I need. What I need is more weld contact area in this spot right here just to help lever against that knuckle. This does that job fine. I chose instead to add this gusset here, which also works, just another lever working against this outer knuckle piece, also tied to that spacer. Everything here, I believe, it should be very strong. I'm looking forward to seeing how this works out. These were also very time consuming, as I mentioned, a couple hours a piece in welding. Then once they were welded and cleaned up, and as soon as they were, cool enough to work with, they went back on the bench. The bearings were all cleaned up. I had Allison working in the solvent tank, cleaning all the kingpin bearings and races up. They went back on the bench. Everything went back together. These things are ready to bolt onto the housings as is. I don't have to do anything except for bolt them on and pump a little bit of grease in those kingpin bearings. Now, as far as the third member, we'll go over there and take a look at that. I've got this sitting on the stand, fresh out of the parts washer. I actually had it, I run it through the parts washer for about an hour and a half last night while I painted the rear housing. And just checked it over, made sure everything looked good externally, and it looks like it's in great shape. So we're gonna run it as is, open diff, and try it out. Basically, all I have to do right now is flip this thing over and drop it in the housing as soon as I get that thing cleaned up and ready to accept it. Now, before we get started on putting this thing together, let's come over here and take a look at the one that's actually assembled and complete. While I had this third member apart, putting the spool in it, I had taken this thing completely apart, disassembled. I pulled this pinion cartridge out. So basically these 8 bolts right here have a pinion bearing right here. Then there's another inner pinion bearing. And then at the end of the pinion gear itself, there is a third bearing that fits into this housing, just a support bearing. So you pull these bolts out right here. After you lift the carrier and the ring gear out, you can slide this assembly out as one unit. So I went ahead and took the opportunity, since I had the ring gear already out, to slide this out, and that actually made it easier for me to set up and measure this bolt pattern and draw it up. So I now have a DXF file of this bolt pattern drawn up so I can design a caliper mount. Now I already have the caliper mounting set up, drawn up from previously building a caliper mount that is on the transfer case on the truck. So I can kind of take those two and overlay them, and now I can build a caliper mount that will bolt onto this pinion. This is a spare rotor. This was one of the original rotors that I designed and cut out for the truck. And then later on, I had decided to add a symmetrical hole pattern on here that I could actually reach through the rotor to access the caliper bolts. Again, that's something we'll get into more when we install these in the truck. But this rotor right here, aside from that symmetrical hole pattern, is dimensionally exactly the same as what's on the truck. So I could bolt it on here and get an idea, you know, what kind of spacing I need for the caliper bracket once I get to the point of building that. The rest of the housing, you know, everything went together very good. Assembled nice, it turns nice, everything works it's really clean. Really happy with how it turned out. As far as the color and the coating and all of this stuff, that is Walmart Rust-Oleum sandable primer and Rust-Oleum flat black in the turbo can. I wanted something low build so that it doesn't affect putting tools on fasteners for bolt checks. You know, if I base clear this, all of a sudden your 7/8 end wrench does not fit on 7/8 bolts very good anymore. So I was trying to avoid that. I will tell you right now, if you haven't used the Rust-Oleum turbo can, those things are nuts. Those things put some paint out. The can is twice as big as a normal spray paint can, and it needs to be because it's just blowing that shit everywhere. I'm happy with the finish, and I really like the color. It's not nearly as flat as I was expecting. I think I was imagining like almost like a chalk black or a barbecue paint black or something, but this has almost a little bit of a sheen, not a semi-gloss by any means, but it looks nice. It will touch up easy. I can get my wrench on my fasteners. I'm super happy with it. No need for powder coat or base clear or nothing on this unit. It's just going to get crashed into stuff anyway. We may do something with the pipe hands. I'm going to talk to Allison about that, see if she wants to do something a different color there. These are not bolted on yet. I mean, obviously they're bolted on. They have 2 bolts holding them in place. That's to keep paint out of my gears in there. It's not even sealed up, nothing. I figured we might change the color there, and even if we leave them flat black, I didn't want to paint all my fasteners. So those will come off. They'll get sealed up. They'll either get painted a different color, sealed up and bolted on, or we'll seal them up, put my new fasteners in, and they'll be done. That'll be decided probably tomorrow. So now I'm already burning up precious time. So let's get over here and get going on this thing. Basically what I'm gonna do first is lift this up with the hoist, set it face down on the table on a couple blocks of wood. I'll move those little stands there, set it face down on a couple blocks of wood. I'm gonna hit it with a needle scaler. Basically that's just a tool for chipping welding slag and stuff away on any kind of welding process that has a slag left over. And what I'm doing with it is actually like back in there where I welded those bulkheads in the housing. You can't get in there with a wire wheel to, you know, knock your little weld spatter and dingleberries and the weld smoke and stuff out of there. I really like to clean that stuff up. I certainly don't want any bits of slag or weld spatter or anything that's loose in the housing. I just don't want that contamination. So what I'll do is I'll get in there with a needle scaler and just basically peen the crap out of it and just scrub that thing around. Any little dingleberry or weld spatter that thing doesn't knock off, it's not gonna fall off. It's gonna be there. Anything that's even relatively loose, that thing will rattle it loose. I'll end up with a little pile of scunginess in the bottom of that deal. I can vacuum it out. This housing will end up really clean inside. Then I can start focusing on getting that third member dropped in there. One thing about the third member is if you look at the main caps on it, they have these machined registers right here. And these 4 points actually fit in this housing in these locations here. So when you set that thing in, it has to be very square and true to the housing as you lower it in there. Or you get it in there very close and you have to kind of, you know, finagle it side to side with a bar, you know, and try and get it leveled up, and eventually you'll just feel it kind of settle in. I can only imagine trying to put those things in like a semi truck facing in this way under a truck. What a wrestling match that must be. I know doing it on the table face down is considerably easier, and it can still be kind of tricky. So here we go. I'm gonna go ahead and just video this time instead of time lapsing. I don't know how much of it I'm gonna keep at regular speed or speed up, but I already time lapsed this whole process on the rear. We'll just video it this time. Actually trying to remember exactly how I had this set up on the rear, and that was only a couple of days ago. Basically, all I'm doing here is trying to get this centered under the hoist as much as I can and stable enough that it's not wobbling around as I'm trying to set that third member in here. So once I start going in with that, you want this thing pretty stable. Getting that thing flat and level and straight and going down there the right direction other than down can be kind of challenging. You don't want to fight two different problems at the same time. But obviously, I have to needle scale this first. That also works out well laying down because all of the crap ends up right here in the bowl where it's easy to get to. Not that there's a lot of junk that comes out of there. It's fairly clean, but we'll get a little. So if you don't know what a needle scaler is, this is it. Just kind of like a pneumatic chipping hammer. And it's pretty, it can get pretty rowdy. It's really loud, so we'll get right after it. I'm gonna go ahead and set my mic in the office so it'll just blow your guys' eardrums out. Now, if you follow some of those really important tips and tricks I was pointing out there, it'll be pretty successful for you. Now, if we take a peek in here, look at that pile of stuff. I would rather not have that come loose and floating around. Now, more than likely, probably less than half of that would have actually come loose in normal conditions, but now none of that is going to make it in the differential. I could probably run a show or two with it now, change the diff oil, and we should have them cleaned up really pretty good at that point. There's a couple of spots here you can see. I don't know if you can see that or not. Let's take a peek in there. Yeah, see that? You see that little dingleberry right there? That guy's not coming off of there. That'll be riding there for the rest of the life of this housing. Now I'm going to grab my vacuum, get it cleaned up, and I might hit a couple of these spots in here with that air hammer. Since I've already got my earplugs in my pocket and the air hammer compressor is built up, I'm going to go ahead and hammer a couple other spots real quick. Now we'll get our sealant up here. Doesn't take a whole bunch of this either. I'll probably use too much, but not on purpose. I'm thinking that's probably pretty good. So we better put some more on. No. There's really not very much on there. Definitely more than it needs, I'm sure, but anything that oozes to the inside is going to be very minimal, and anything that oozes to the outside can be removed. Cutting a little cone off the outside is way better than fighting a leak. Feel sorry for the guy that's got to take that out. And we'll just snug enough of these up. Hold it in place. I'm going to dig a little bit of that sealant out of these holes here. I don't need to push all that silicone down in the housing. What's on the end of the bolts already can stay there. My battery was dying on my camera, so I had to let it charge a little bit. Brought you guys back now. You didn't miss nothing. All I did was finish installing some bolts in this thing. As a matter of fact, I ended up putting different bolts in here altogether. So I took these bolts here out of that axle because they are a cheap, like a grade 5 bolt from the hardware store. That way I can paint them. And when the paint's done drying, I can take these bolts out of this unit, and they've got the dried up silicone from going through the holes stuck to the end of them. And after it's all painted, you install your good grade 8 fasteners, which also sold at our hardware store. So they sell that stuff by the pound. If you're going to do something like this, sometimes it's worth it to go buy a couple of pounds of miscellaneous bolts, cheap hardware, you know, grade 2, grade 5 stuff just for this type of purpose. But anyway, now I've got these bolts in here. It's snug down, good, solid. It's not like they're torqued or anything. They're coming out again later, obviously. What I'm going to do next is stand this housing up and set it back on these little mini steel sawhorses, because it is going to get chained down to the table. Because actually the next step is to put the champagnes and the knuckles on, and the 7/8 bolts that mount the knuckles, the champagnes, to this flange have a torque spec of 460 foot-pounds. Now I have a torque wrench that'll go 460 foot-pounds, but I can't get it on there. Probably show you that a little bit later, but you just physically cannot fit the torque wrench with a socket on that bolt. So what I have to get as close as possible is a 12.7/8 end wrench that I've cut the open end off of, and 28 inches of 1/8 inch wall, 1 inch square tubing. And you can get pretty ignorant with that setup. So I will be getting ignorant when I get to that point. Maybe later on I might build an adapter. I've seen where you can actually use a wrench, torque wrench on a wrench, as long as it's 90 degrees. It should be the same torque. I might try to fit something like that on there. I'm pretty sure that I'm getting them tight enough with that setup. If they're going to go somewhere, another 20 or 30 foot-pounds of torque is probably not going to make any difference in the world. I would like to know, though. Settles a little curiosity from myself. For anyone curious, right now at this current state right here, this thing weighs 605 pounds, 606 pounds. So the housing with nothing in it came in at 340 pounds. And then when Allison and I loaded up the rear axle, we were taking bets on it. She guessed 500 pounds, and I guessed closer to 6, and it ended up being 606 pounds. So that puts that chunk right there, right around 250 pounds for that third member. It's pretty crazy. Also notable on that topic, the knuckle itself, welded out with all the bracketry on there, ended up being like 104 pounds. And when you add kingpins or kingpin bearings, champagnes, caps, bolts, everything to assemble the knuckles and the champagnes, those come in right at 200 pounds each. So as you can imagine, these axles are ridiculously heavy. That complete unit laying on the floor right now currently is 1,750 pounds. And we still have wheel tethers and steering to put on them. So I'll bet they're really close if they don't break over 2,000 pounds per axle. Now we're ready to install the knuckles. I'll go ahead and clean out these bolt holes, just some compressed air, maybe a little carb or brake clean or something like that. And then they'll be ready for some more big heavy parts. Okay, we got our housing on our stands, got her chain down so I can really reef around on it. Table might move, but this is not gonna roll around. I've already come in here and put a dab of anti-seize in each one of these threaded holes and run one of my 12-point bolts in and out. All 10 holes on this flange, just to make sure there isn't a little hooky in there or some grit or something that will cause a damage to the bolt or cause an issue with it tightening up properly. I've also come in and put just a tiny film of silicone in this register, and all I'm doing there is sealing that champagne to that tube in there. So basically I'm just trying to keep the oil in the housing or in the champagne at least to the wiper seals on the ball. We'll get into that more later, but right now it's about 8 o'clock at night and I really want to get at least one of these knuckles on here before I go home and get a nap so I can get up at 3 o'clock in the morning and go to work again tomorrow. I was thinking that was very, very messed up. So I'm one bolt hole off, and I was thinking, man, that caster right there is not what I was shooting for when I put this thing together. I'll try and wrestle this around here a little bit and get her lined up with the correct position. I might have to set it down and go to a different, I'm gonna go to a different bolt hole here. Take two. That doesn't hang any better. Must be the weight hanging on the front of that knuckle. That's okay. I only have to get one started. In fact, I was told that you can't even get longer than 2-inch bolts in this location. It just physically won't fit in there. These are 2-inch bolts that I've machined the end off. I've taken about 25 thousandths off the end of the bolt to make certain that they will not bottom out where this flange goes up against this 1/2-inch plate. They fit in no problem, but I'm sure the next step in a bolt would be a 2.5, and I can see where that probably just wouldn't physically fit in there. Now, something that is kind of interesting is if you look at the Champagne from a Rockwell PS250, this is actually pretty long in this area. If you were, and also you don't have to have the inner half of the knuckle on the Champagne when you mount it on that one. The whole knuckle is one assembly, I believe, and it goes over like a Clark where it actually fits over the ball. You have the bearings in the ball, and then the caps actually have the pins that fit down in the bearings, or they hold the bearings, and the caps go down in the races in the ball. So like on a Rockwell PS250, it's far enough in there, you could actually use a wobbly socket and an impact wrench to tighten those up, zip them all in there. That would be convenient, but that was the reason, this is the whole reason right here that I run all of these bolts in this flange before I even started, just to make sure I didn't, you know, this is almost, I mean, it's almost hand tight. It's just easier to throw this gear wrench on here and snug them up. And then I'm really not even snugging them up. I'm just running the bolts, the head of the bolt, or the washer actually, just up to where it touches the flange of the Champagne. I don't want to tighten them down at all, because if I do have to manipulate it a little bit to make sure that a bolt starts properly, it doesn't try to cross thread or anything like that, I can kind of see, like this one here's, oh, it was just me. If I need to try and roll it in that little bit of range of motion that it has, I can do that. There, all of the bolts are started. All I have to do now is work my way up. I just kind of work my way around, tightening all of these bolts up, pulling that Champagne up tight against that flange. And here's what I was going to show you. You can get the socket on there. You're not going to get a torque wrench in here. It's not going to work out. Maybe a guy could cut a socket down. Maybe, I don't know if you could get, either way, you're not going to do any good with a 1/2 inch torque wrench anyway. I would need to get a 3/4 inch socket in there. Maybe a guy could take a 7/8 end wrench and weld a socket here. And then as long as the wrench and your torque wrench are 90 degrees to each other, it should still torque properly. I may try to do that before it's all said and done, but I'm not doing it tonight. I'm going to set this thing back up, probably throw it on time lapse, because all I'm doing is a whole bunch of pulling on a handle. I don't need to talk about that. There, I've got those all tightened down as tight as I'm going to get them with this system. Now, I guess I could have just taken the mic off and recorded that in real time. Mostly I just didn't want you guys to hear me huffing and puffing, pulling on that piece of tubing. It's a pretty good workout. I still don't believe that I'm getting 460 foot-pounds on it. I mean, I am only working with about 28 inches of tube, and you know, you'd have to basically be lifting or pulling at least 200 pounds to be even getting close. I'm not sure I'm doing that exactly. I do know that we're getting pretty close to finding the limit of the wrench itself. I think it's got one more corner in it, and that's all I need. That's going to do it for tonight. I'm going to go ahead, close up the shop, go take a shower, eat some dinner, get a nap, go to work tomorrow, and then immediately hit that thing tomorrow night. Get that other corner bolted on there. I don't even know. I might go ahead and set it up, just time lapse it, just so I have it on video. And then I'll bring you guys back once I get that corner on, and then we'll start looking at what I've got to do as far as axle shafts, inner axle shafts, spindles, hubs. There's a bit of work to do yet. We can look at it on this axle over here, but I'll be showing you on the other hubs anyway. These are part of the wheel tethers. So if you watch a monster truck on TV and the tire busts off of it and the wheel goes rolling away, this here is designed to keep the wheel hub assembly close to the truck if it breaks off. So say the spindle, this spindle bolt's here, the spindle goes into the hub. If something basically from the spindle out breaks and that tire tries to take off, there's a couple of different systems. Both of them use this, a ring like this. So you have this ring on here. One system, it will have basically a tab. You would bolt a cable to here somewhere. That cable would make a loop around your wheel hub, and if this area broke and it tried to get away from the truck, that cable would choke up on it and basically just keep the wheel hub and the tire and wheel in close proximity to the truck. You know, keep it from rolling across the stadium floor or arena floor and getting into the crowd or the parking lot, anything really. More common nowadays is people build brackets that basically bolt on to either these two or all four of these holes. And it's just a flat plate that will come out. It's gusseted and reinforced. It comes out past this ring. And then there's a pair of, half circles that bolt around this piece. And then they will have, 3 or 4 bolts that hold these half circles to that upper plate, which is bolted to the knuckle here. Now, if something breaks there, you've got these half circles of steel plate that they basically wad up in there, and still they do the same thing. I'm pretty sure I'm gonna go ahead and build the plate ones. I was originally thinking the cable would be better just because I think they're maybe easier to replace if you have something happen. But the plate ones, the steel plate ones are ultimately they're cleaner. Probably easier to work around. It'd be better if you have to disassemble anything. Those steel cables or the chokers rubbing on this thing, you might get frayed cables that, hurt your hands or hurt someone that's trying to help you do something on here. So I'm not too keen on that. Anyway, kind of getting off on a tangent. We'll worry about that tomorrow. We'll get back on this thing, tomorrow evening and go from there.
Tomorrow.
There it is. I've got that second champagne and knuckle attached to the housing here. While I was at it, I went ahead and welded both champagnes onto the housing. There's triple pass, three individual welds right here on each one. That's really common, especially on the Pettibones because of this big flat area to start with. I was a little bit hesitant at first because this champagne is actually 4340. And to weld 4340, you should preheat and post-heat that material before welding. So if you look closely on the time lapse, you can see that I drug the torch and the rosebud in here. I warmed this area up to about 450, 500 degrees, welded it up, and then I also used that needle scaler to kind of peen it, somewhat stress relieve it, and then I covered up with the welding blankets to let it cool a little bit slower. Now technically you should probably heat this thing up to 500 degrees, do your welding, any stress relieving you might want to do, post heat it, and then let it cool slow. That would probably be, the perfect world, a structural weld, something along those lines. Most guys are probably going to just run a couple beads up there and call it good. But I have seen these welds popped off of these champagnes before, so I wanted to put a little bit more effort into it. So both of them are done. Once that was finished, I drug the other two wheel hubs out. I've got one sitting over there. I've got one sitting over here. I took all of the planetary guts out. They're sitting on the bench here. Spindles, got the carriers, planetary gears. These two hubs were actually cleaned up when I first took this stuff apart. So I went through them, cleaned them up very thoroughly. Then I put them back together, threw them under the bench out in the other shop. Last night I drug them back in, took them apart, and what I'm going to do is put my plugs in here to protect the bearings, set these wheel hubs individually out in the parts washer, and run them through there for, I don't know, probably start with about an hour, maybe an hour and a half, and try and get that yellow paint washed off of there. Sometimes we get the parts washer hot and the right amount of lye in there or caustic, it'll wash that paint off, and then you've got a really nice area to weld the tether rings to. And then when I paint, I'm not painting over some of this old flaky industrial paint. So time to get after it. I'm really hoping to have this whole assembly done by the end of the night tonight. I don't have to work tomorrow, so it'll probably be a late one. Well, I did not quite get this front end completely assembled and painted last night. By about 1 o'clock this morning, I was pretty well cashed in. So I went home, got a nap. Now I'm here this morning to get this thing buttoned up. I did, however, get a whole bunch of stuff done. I just didn't quite get it assembled. So as you can see, I got the hubs all cleaned up. They cleaned up really nice in the washer. Got the tether rings welded on, so that's all done on both hubs. I run some other parts through the washer, the pipe hands or the planetary covers. They turned out pretty clean. It's got all the 2 layers of industrial paint washed off of them. The spindles also went through the washer, so they're all cleaned up. While parts were washing, you throw them in the washer, they run through there for 40, 50 minutes, and maybe an hour. Just depends on what I'm doing. While they were washing, I built these thrust buttons for the inner axle shafts. That's all done. Got my butyl grommet seals installed on both shafts. And then I drug out a pair of stub shafts and Rosetta joints and got those packed full of grease. Basically, all I have to do now is slam all these parts in that front housing and we will have a complete front differential. So what I'll do is probably time lapse getting all of this crap on the table, up on the housing and all put together. Then I'll bring you back and we'll go into more detail on actually assembling one of these planetary assemblies. Putting in the planetary carrier and the gears and all of that stuff, that the inner workings of the wheel hub. So let's get this thing slammed together. I'll bring you back and we'll do at least one corner real good and show you what's going on there. Now the axle shafts are in, the spindles are on, all the spindle bolts are torqued to 250 foot-pounds. Now we can get busy putting the wheel hubs and all the planetary parts together. So in this wheel hub, there's a couple of wheel bearings, and kind of the unique thing, another unique thing with the Pettibones is they have an inner wheel seal here that keeps planetary oil separate from your wheel bearing oil. I'm pretty certain that these things are probably oil bath bearings from the factory, and I'm not sure why the dual seal. I don't know why they don't want to share oil. Maybe they're preventing contamination from one failure or another, you know, keeping it from affecting the other side. Either way, I decided to go ahead and grease these bearings. So what I did is I took my slug that I use for lifting these things into the parts washer and basically just keeping contamination out of the bearings. I have two of these slugs, they fit from either side. I took one of them and drilled and tapped for a grease zerk, and then drilled a grease passage into the grease zerk hole. And as you can see, it will apply grease in between the seal and the bearing. So basically it just pumps grease in between these two. And I have a through bolt with an H-bar on the back side. I just turn the grease gun on and watch from the back side until it starts pushing the grease through the rollers. Once I get lubrication, grease pumped through, all the way through the rollers on one side, flip it over, go ahead and put the slug in the back side and do the same on that inner wheel bearing. So actually I did all that stuff last night right after welding those tether rings on. So right now I've got a lifting eye set up here. I can pick this thing up with the hoist there, carefully swing it over and get it placed on the spindle. Once I have that in place, the next step is to take this planetary carrier here, which splines onto the spindle. As you can see, it's got a seal surface here that matches that inner bearing seal. And then you have a lock washer, a lock tab washer, and the spindle nut. So you tighten the spindle nut to hold the planetary carrier in place. That also sets the preload on the wheel bearings. Once you get it set where you want, you bend one of these tabs over to lock it in place so it won't back out. And then we can start assembling planetary gears. So I'll try and get you set up where you can see what I'm actually doing as I'm doing it. Now you have to be very careful not to fold this seal lip over, because it's actually in there with the spring side towards this carrier. So if you don't have it lined up good, it's fairly easy to fold that lip over. I'm going to dig a little of this excessive grease out so I can make sure it goes together properly. See, it feels like it's hanging up a little bit funny going in there. I'll take it out and see. Maybe I need to pick that hub up just a little bit. No, it was going okay. Try again. Special socket. It fits this nut really pretty tight. It's almost kind of a pain. But some of these spindle nuts that I've pulled out of some of these planetaries are beat to crap. People use punches and hammers, maybe air hammers. Looks like they use pipe wrenches. I don't know what people choose to use sometimes, but they're pretty rough. This set here is pretty decent. My socket does fit that thing really snug. I don't know what the specs are on the wheel bearings. Like an Axle Tech, you torque them to like 280 foot-pounds or 300 foot-pounds or something, and then back them off a certain amount and then retorque them. I think that's more for seating the seal on those. With this wrench here, I probably can't over-torque this bearing. Not sitting on the bench. I get it as tight as I can, and I can still spin it by hand, I'm probably fine. Now I'm just looking to see where I land on one of these tangs on this lock washer. That one's pretty much right on the money. I think it's probably tight enough. go ahead and lock her down. Now we'll get all these planetary gears put in here. Like I'd mentioned before, these have already all been cleaned up, somewhat lubricated. They actually have lubrication holes between a pair of teeth. Each gear has one set of holes. So I'm going to initially install this stuff with those holes up. Right there in that tooth, so that I can put a little bit of oil in that tooth, use it like a channel, let it just drip a bit of oil into those bearings, and I'll do that with all four. Also, each one of these planetary gears has a roller bearing in it, a pair of roller bearings actually, and inner races. So you have to make sure that all of those parts are in there. Here are the bearings. Again, you don't want to forget the thrust washers. Each one has a thrust washer for the inside and the outside. The thrust washers are also brass. We probably want to keep that in mind when choosing a lubricant to put in these. And then you've got the sun gear. Sun gear splines onto the axle shaft. Fortunately, the splines stick out just far enough that I can get the gear splined onto the shaft before I worry about lining it up with the planetary gears. Also, the end of the stub shaft, the Rezepa, is threaded, so you can put a bolt in there, kind of like a cam installing tool, because you've got to manipulate the end of that axle shaft just a little bit. Just like that. Really nothing to it. Another thrust washer. And then we can install this carrier. Or I guess that's kind of the carrier. This is more like a girdle or a support. And I actually have this marked. I don't know how important it is. I'm sure everything when it's machined is fairly precision, but I like to try and put this stuff back the way it came off. So, you know, you've got these axles, I guess you might call them. They fit in a nicely machined hole here, and then you've got 4 dowel pins. So if I know it came off good and I install it back in the same position, I don't have to worry about fighting them on there. Of course, the dowels start first. And you have to watch the axle shaft because the axle shaft actually fits in this bearing. Seeing the axle shaft come up there. Sounds pretty well bottomed out. Looks pretty well bottomed out. I really didn't have to hit it hard. It was just more saving my hands using that hammer. Now there's a snap ring that goes on the end of the axle shaft, so I'll thread this bolt in here, pull the axle shaft out to expose the snap ring groove, just like that. I'll leave that there in case I have to tug on it. Let me go get my bucket of hardware. My bucket of hardware doesn't have a snap ring in there. But I've taken enough planetaries apart that I have a bucket of snap rings. So we're good. Just like that. Next, we have 4 washers that go on what we'll call the axles, these carrier pins. And then there are 4 castle nuts, which hold everything in place. And then these do not tighten up much at all. It's a lot, kind of like a little 3,500 pound utility trailer axle or something. If you tighten them up too tight, you'll burn a bearing up. These ones here, if you snug these nuts down at all, the whole hub assembly will quit turning. It's like it smashes down too tight on these thrust washers or something. So if you can run them down by hand, if it's close to the next notch, so these pins are actually drilled for cotter keys, and if you can just snug it up just a little bit, I'm going to double check, make sure that one's there, then back it off 1 notch. That's pretty good. Just work my way around all 4 of them. See, I haven't even hardly tightened that down. Well, I guess it still turns, just feels snug. If I go to that spot, not terrible at all. Back it off 1. Cotter keys to make sure those don't back off. And I'm just going to bend them out just enough to keep them from falling out. So anytime a guy has to get in here and do something, I may have to retorque the wheel bearings or something like that. I don't want to have to mess with these cotter keys too much to get them out. That should do it. There's one side assembled. Go slap the other side together, and then we can get this thing ready for paint. After letting the paint cure, I went ahead and bolted on the other pie pans that Allison had painted up. Followed that with installing my custom engraved 7075 aluminum tie rods built by Summit Machine, along with the large EMF heim joints. And that pretty much concludes the axle build. The next step is to get them installed in the truck so I can finish steering plumbing and brake parts. However, that's going to come in the next video because I'm going to go ahead and wrap this one up. As always, thanks for watching. Have a good one. We don't have to go far, maybe probably less than a foot. Crazy. Thing is shaped like it was, rolling around like an egg instead of falling off the table. That would have been terrible.
That would have been bad.
That's probably good enough.
Probably.
Yeah. Put that jack back there.